students, already we discussed about the first law of thermodynamic, delta Q is equal to delta U plus delta W, and also different type of the thermodynamic process. We derive the equation of the work done during the isothermal process and also the adiabatic process. Now the remaining thermodynamic processes are isoquake and also isobaric process and also cyclic process. Now we are interested to derive the equation of the work done for this type of the processes. Now explain the isoquake process and also obtain the work done for the isoquake process. Now first thing, what is the definition of the isoquake process? Isoquake process, that means the process during which the volume of a system remains constant. Volume does not change. That means the piston is fixed in a cylinder. As we consider the piston cylinder arrangement like this way. There is the cylinder. Now there is piston can move up and down without the friction. Here the gas or the system is filled inside the piston cylinder as well. If the piston is fixed, so what's happened? The volume of a system, that means the volume of a gas is now constant, in spite of the heat energy supplied. There is no change in volume. No change in volume, therefore delta V is equal to 0 for this process. So we are going to discuss about that. If the volume of a system is constant, so what's happened is the system is absorbed or release the heat. Now, first the definition of the isoquake process, the process during which the volume of a system remains constant, is known as isoquake process. In isoquake process, volume is constant, therefore change in volume delta V is equal to 0. Now the work done, W is equal to P into delta V, but the delta V is equal to 0, therefore work done is also 0 for isoquake process. Here the work done for the isoquake process is 0. So what's happened? When the system absorbs the heat, or how the system releases the heat. Okay. For that purpose, from first law of thermodynamic, delta Q is equal to delta W plus delta U. But delta W is 0. That means the work done during the isoquake process is 0. Just we discussing. Therefore, delta Q is equal to delta U. That means whatever the exchange of the heat take place between the system and surrounding is make the change in internal energy of a system. Again, from first law of thermodynamic, delta W is equal to 0 for isoquake process. Therefore, delta Q is equal to delta U. That means the exchange of the heat between the system and its surrounding makes the change in internal energy of a system. That means, as the heat absorbs, the temperature and internal energy of a system increases. And if the heat released, the temperature and internal energy of a system decreases. So when the heat is absorbed by the system, in that case, the work done is 0 because the volume does not change. Therefore, this absorbed heat make the increase in temperature and also internal energy of the system also increases. When the heat is released, at that time what's happened? The temperature of the system decreases and hence the internal energy of the system is also decreases. Now, for a given amount of the heat, the change in temperature can be determined by the specific heat capacity of a gas at constant volume. Again, for a given amount of the heat, the change in temperature can be determined by the specific heat of a gas at constant volume. Therefore, Cp is equal to delta Q upon mu delta T. Delta Q is equal, Cp is equal to delta Q upon mu delta T. Therefore, change in temperature delta T is equal to delta Q upon Cp into mu. Cp into mu. Here volume is constant, therefore Cv. Again, what is the isoquake process? The process during which the volume of a system remains constant is known as the isoquake process. Okay. In isoquake process, volume is constant, therefore change in volume is zero. Therefore, work done during the isoquake process, W is equal to P delta V, but delta V is equal to 0. Therefore, work done during the isoquake process is 0. From first law of thermodynamic, delta Q is equal to delta U plus delta W, but delta W is 0. Therefore, delta Q is equal to delta U. Hence, the heat absorbed, the temperature and internal energy of a system increases. And if the heat released by the system, the temperature and internal energy decreases. Thus, for a given amount of heat, the change in temperature can be determined by the specific heat of a gas at constant volume. Therefore, the definition of specific heat at constant volume, Cv, is equal to delta Q upon mu delta T. Therefore, change in temperature, delta Qt is equal to delta T is equal to delta Q upon Cv into mu. So, from this equation we can find out the change in temperature of a system at constant volume. Okay. After that, the remaining process is isobake process. Define isobake process and obtain the equation of work done in such process. Now, isobake process, that means the pressure of a system is constant. So the definition of the isobake process is that the process during which the pressure of a system remains constant. Again, the process during which the pressure of a system remains constant is known as isobake process. Now, again, the process during which the pressure of a system remains constant is known as isobake process. Here the pressure is constant. Okay. According to the graph P versus C, the system undergoes from initial state 1 to 2 at constant pressure. Therefore, in initial state, pressure is P, volume is V1. In final state, the pressure is P, volume is V2 because the pressure is remains constant. The pressure remains constant from the state PV1 to PV2. Therefore, the work done by the gas at constant pressure, delta W is equal to P delta V. So here the P is constant, volume changes from initial V1 to the final V2. Therefore, P V2 minus V1. Therefore, we can add P V2 minus P V1. Okay. But from equation of an ideal gas, PV is equal to mu RT. Therefore, PV1 is equal to mu RT1 and PV2 is equal to mu RT2. P is constant. Substitute the value of PV1 and PV2 in equation 1. Therefore, delta W, the work done W is equal to mu RT2 minus mu RT1. Mu R is constant, therefore T1 minus T2. T1 minus T2. Hence, the internal energy changed with temperature. So, what's happened? Here, the internal energy of a system also changes with temperature at constant pressure. Now, some of the absorbed heat is utilized for increasing in internal energy and rest utilized to do the work. Again, at constant pressure, that much work done, W is equal to mu R T1 minus T2. So what's happened? When the heat energy is absorbed by the system at constant pressure, so some of the absorbed heat is utilized to increase the internal energy and to make the increase in temperature, and rest energy utilized for the work done. Therefore, the change in temperature for a given amount of the heat can be determined by the specific heat of a gas at constant pressure. Again, the change in temperature for a given amount of the heat is determined by the specific heat at constant pressure. Again, already we have the definition of the specific heat at constant pressure, Cp. So here the pressure is constant, so whatever the amount of the heat is given, that is utilized to increase the temperature. Therefore, Cp is equal to delta Q upon mu delta T. So how much increase takes place in temperature at constant pressure? Delta T is equal to delta Q upon Cp into mu. This equation is same as, that is at constant volume, that is at constant pressure. Again, what is the Isoquake process? The process during which the pressure of the system remains constant is known as Isoquake process. According to the graph P versus V, right? The pressure remains constant, system undergoes, or the system goes from initial state PV1 to the final state PV2. Therefore, work done by the gas at constant pressure, delta W is equal to P delta V. Therefore, P is constant, volume changes V2 minus V1. We multiply PV2 minus PV1. Now, for an ideal gas, we know the equation of state PV is equal to mu RT. Therefore, PV1 is equal to mu RT1 and PV2 is equal to mu RT2. We substitute the value of PV1 as mu RT1 and PV2 as mu RT2 in equation 1. Therefore, we obtain the work done is equal to W is equal to mu R into change in temperature. Therefore, mu R into T1 minus T2. Hence, the internal energy change with temperature. Therefore, the sum of the absorbed heat utilized for increasing the temperature. Here the temperature is changed. Therefore, the internal energy of the system is also changed at constant pressure. Therefore, we have written, hence the internal energy changed with the temperature. Is the work done? So temperature is also changed at constant pressure. Therefore, the sum of the absorbed heat is utilized to increase the temperature or the internal energy, and the rest utilized for work done. So whatever the amount of the heat absorbed at constant pressure, the some part of the absorbed heat is utilized for increasing the internal energy or the temperature of the system, and remaining energy is used to do the work. Okay. Now, at constant pressure, the change in temperature for given amount of the heat can be determined by the specific heat of a gas at constant pressure. Already we have the definition of specific heat at constant pressure. Therefore, Cp is equal to delta Q upon mu delta T. Therefore, delta T is equal to delta Q upon Cp into mu. That is the specific heat at constant volume. That is the specific heat at constant pressure. In both cases, in isoquake and also isoquake process, we can know the change in temperature of the system. Okay. Now, what is the cyclic process? already we defined a process in which a system undergoes series of changes, and the system returns back to its original state. Such process is known as cyclic process. Now listen here, in cyclic process the thermodynamics start from its equilibrium state. If any state variable changes like as the pressure, volume, temperature, so the state of the thermodynamic system is changed. So this way a system undergoes the numbers of the series of changes and last it returns back to its original state. So such process is known as the cyclic process. Last time we also take the one example of that in steam engine of railway. The working substance is the water. As the water enter in piston cylinder as well. So here from the outside of cylinder, here the fire take place due to the cold of the wood. So whatever the water is enter, at that time what's happened? So due to the outside of the fire outside of this cylinder, so this water is converted into the vapor. So as a result, the volume of the system is increased, therefore piston moves up. So this heat or the vapor is taken out from the cylinder. Right? New water is entered, again converted into the vapor. This vapor is taken out of the cylinder. This vapor taken out from the cylinder again cool down and convert into the water. And then this water is again returned in the piston cylinder as well. So here initially the initial state of a water is at temperature and pressure of atmosphere in water form. So when it enters in cylinder, it converts into the vapor at high temperature and high pressure. Again, this vapor is converted into the water. Again, it converts into the vapor. So here, the working substance water undergoes the series of changes or the series of thermodynamic processes and return back to its original form or the initial state. So such process is known as the cyclic process. That is the example for the cyclic process. Now, our definition of a cyclic process is that a process in which a system undergoes the series of changes and the system returns back to its original state or the initial state. Such process is known as the cyclic process. Okay. In cyclic process, the initial and final state of a system are same. Therefore, the change in internal energy of a system is zero. Therefore, the change in internal energy of a system is zero. Therefore, for cyclic process, delta U is equal to 0. Again, keep in mind that in cyclic process, the working substance returns back to its initial state. Therefore, state does not change. Therefore, the change in internal energy of the system is 0. Now, from the first law of thermodynamics, delta Q is equal to delta U plus delta W, but delta U is equal to 0. Therefore, delta Q is equal to delta W. If the system absorbs the heat, the work done by the system on the surrounding, and if the system releases the heat, the work done on the system by the surrounding. Right? So there is the relation between the absorbed heat or the heat and work done by the system in case of a cyclic process. Again, what is the cyclic process? A process in which a system undergoes series of changes and the system returns back to its initial state. Such process is known as the cyclic process. In cyclic process, the initial and final states are same. Therefore, the change in internal energy of a system is 0. Therefore, delta U is equal to 0. Now, from first law of thermodynamics, delta Q is equal to delta U plus delta W. But for cyclic process, delta U is equal to 0. Therefore, delta Q is equal to delta W. If system absorbs the heat, the work done by the system on the environment. And if the system release the heat, so work done on the system by the environment. Right? So there is the information or the explanation of isoquake, isobake, and also the cyclic process. Now we are going to derive the work done for cyclic process.